The F-35 Lightning II presents a severe contradiction. It defines the current standards of air dominance, yet it consistently fails to meet its own targets for peacetime readiness. The aircraft's tactical reputation is tethered to a massive support infrastructure, with an estimated sustainment cost of $1.58 trillion over the program's lifecycle. This creates a unique financial anomaly. At roughly $82.5 million per unit, the F-35 is currently cheaper to purchase than legacy aircraft like the F-15XE or the Eurofighter Typhoon. However, the procurement price is only a fraction of the total ownership cost. Auditing the F-35's ledger requires looking past the initial purchase and into the daily expense of keeping the fleet airborne. To evaluate the program fairly, we must weigh the platform's unprecedented data-gathering capabilities against the friction of its high-maintenance architecture. Modern air superiority requires the F-35 to function as a command and control node, prioritizing the distribution of battlefield data over traditional dogfighting metrics. The system achieves this through sensor fusion, a process that automates the collection and synthesis of radar, infrared, and electronic signals into a single integrated tactical picture. The helmet-mounted display system projects the resulting data directly onto the pilot's visor, allowing them to see through the airframe and track threats in every direction simultaneously. Information flows into the jet from the electro-optical targeting system and distributed aperture system, identifying targets miles away. The multifunction advanced data link then shares this fused picture with friendly ships and older aircraft, which lack sensors to see these threats. This networked approach allows the F-35 to serve as a force multiplier, improving the survival rate and combat effectiveness of every other asset. The 388th Fighter Wing demonstrated the utility of this network during Operation Midnight Hammer, where F-35s were tasked with neutralizing a modern integrated air defense network over Iran. By utilizing onboard electronic warfare and targeting systems to suppress Iranian radar sites, the F-35s created a secure corridor for B-2 bombers to reach their objectives in a heavily contested environment. Providing this level of situational awareness to the joint force is the central justification for the program's massive investment. The logistical strain began with a single engineering goal: creating a common airframe architecture to serve the Air Force, the Marine Corps, and the Navy simultaneously. The Air Force's F-35A is the baseline model, carrying an internal 25mm cannon and up to two 2,000-pound bombs within its stealth-optimized internal bays. However, the Marine Corps required a short takeoff and vertical landing variant, the F-35B, to operate from small amphibious assault ships. To make vertical flight possible, engineers inserted a large Rolls-Royce lift fan behind the pilot, which forced a significant reduction in the aircraft's internal weapons and fuel capacity. As a result, the F-35B must trade firepower for flexibility, carrying only 1,000-pound class weapons internally, compared to the larger capacity of the F-35A. Supporting these three different mission sets required the Pratt & Whitney F-135 engine to be incredibly powerful, but it also necessitated a complex mechanical architecture that is difficult to maintain. Because many components, like the lift fan or specialized landing gear, are unique to each variant, the global supply chain is fragmented rather than unified. The program achieved its goal of multi-service commonality, but at the cost of a long and expensive logistics tail. These architectural choices result in a cost per flight hour for the F-35A that ranges from $34,000 to $42,000. Fuel accounts for 12% of the hourly expense. Spare parts add up to $5,000. Contractor logistics support adds another $7,000. But the largest expense is specialized maintenance labor, adding $18,000 per flight hour. This is because the F-35 requires approximately 13 maintenance work hours for every single hour it spends flying. Managing such a specialized industrial footprint means that any shortage of parts or qualified personnel creates a physical bottleneck that grounds aircraft for weeks. The ledger shows that air forces are paying for a flying sensor platform that demands far more ground support than any of its predecessors. This maintenance burden has a direct impact on readiness, with mission-capable rates for the fleet averaging only 50 to 51%. To manage costs and reduce wear on the airframes, the Air Force has restricted the F-35 fleet to about 195 flight hours per aircraft annually, well below original targets. Ground inspections are complicated by the airframe's density, as mechanics must navigate dozens of access hatches and auxiliary doors to reach critical internal systems. The high degree of proprietary technology means that ground crews often cannot perform repairs without direct contractor oversight, further slowing the return to flight. If the aircraft cannot fly, its advanced tactical sensors provide no value. The F-35's greatest challenge is overcoming the friction of its own logistics. The F-35 program is currently caught between two realities. It is a highly effective combat platform that is also a staggering logistical burden. Nations investing in the jet are paying a premium for the unified, real-time tactical picture it provides to the entire military. Future success depends on stabilizing the Technology Refresh 3 software and opening the supply chain to reduce the current maintenance bottlenecks. With the fleet planned to serve until the year 2088, the Pentagon must find a way to lower the barrier to entry for daily operations. For the F-35 to remain a viable centerpiece of the air fleet, its logistics tail must eventually stabilize, as technical superiority is nullified by a lack of operational readiness.